This code here is the wrap. In the classic game Asteroids, which we're kind of making a similar thing to, when an asteroid goes off the right hand side of the screen, it comes back on the left hand side of the screen, and when it goes off the bottom of the screen, it comes in on the top of the screen. This is wrapping, and if you think about it very carefully, you realize that this makes the world space of the game into a torus. That's kind of neither here nor there because the screen's still flat and the player still thinks it's flat. But it makes for kind of an odd topological shape if you think about it. It's not really a sphere. So this code is actually pretty simple. We're just saying that while we're off the right side of the screen, move us back one screen width. And keep doing that until we're on the screen again. And we do that for all four sides of the screen, and hopefully we'll stay where we're supposed to be. Then here's a piece of code that finishes up the update function of SpaceObject. And it basically breaks it out. It says if my type is an asteroid, then do something here. And then return, which means get out of this function. Don't do any more. Go back to the previous function. And then the other thing, of course, says if it's player, then do this. So basically right now we have nothing going on in the brains of either the asteroids or the player. That's where we would put things if, for instance, we wanted to control the player with the arrow keys, or if we wanted the asteroids to home in on the player. This is the code. This is where we would put that programming code. So we're done with the update of SpaceObject. Let's look at the draw of SpaceObject. It takes a sprite batch called SB, because that's easier to type than sprite batch. And again, it breaks it out. It does two different things depending on whether this particular space object is an asteroid or a player. You can see that if it's an asteroid, it draws an asteroid. And if it's a player, it draws a player. Now, one thing about this way we draw is that when we draw a bitmap, and I've probably said this before, you're drawing starting at the upper left of the bitmap. So when you say x equals 200, y equals 100, you're not saying that you're centering the bitmap on that spot. You're saying that you're starting drawing the bitmap on that spot at the upper left corner of the bitmap. So if the bitmap is 100 by 100 and you drew it at 200, 100, then the lower right corner of the bitmap would wind up being 300, 200, if you follow me. So the so-called origin of the bitmap placement would be in the upper left corner of its own image. That's sometimes useful and sometimes not. There's a lot of reasons why you would want the origin of an image to be in the middle of an image. It can make things a lot easier sometimes. And so oftentimes what we want to do is we want to draw the image in the spot where the object is, but we want to push it left and up by half of the width and the height of the image. And this will put our image, superimpose our image right on the center of the dot of where the object's supposed to be. In situations like this with asteroids and player ships, it actually makes a lot of sense to do it that way. So what we're doing here in this code is we're finding the width and height of the bitmap of the image we're drawing, dividing that by 2, and subtracting it from the actual game position of the object to get how we're going to draw this object. So this business of the code of minus 120 divided by 2, minus 114 divided by 2, as it says here in the comment, that business is about making sure that the art centers on the point that represents the object. And we're drawing for asteroids, and separately we're drawing for player. So now we know what's going on with SpaceObject. SpaceObject could be an asteroid or it could be a player. It has an enum for both, and it has lists for both. And it has common stuff like type and position, velocity, and an isDead flag. And then it has a constructor and an update and a draw. So let's go back and look at game1.cs. This is where we actually run our whole program. But now that we understand what SpaceObject is, we have a better idea of what we're looking at with the game1.cs code. As you can see, we've got the namespace asteroids, as we should. It's a game1 class. We've got graphics and sprite batch. We've got a variable called E, which we set to 0. We've got a constructor, an initialization, and a bunch of load content. Let's look at what we do here. First off, we make a sprite batch and a helper. That's nothing new under the sun. But then after that, we're defining our asteroid list and our player list. So I got through saying that asteroid list and player lists are variables that are static and part of space object. And that's fine, but even if they're static, they still need to be created initially. And that's actually literally what we're doing here. In this code, which has nothing to do with space object, we're saying new list space object. We're making the list. We had the variable, now we've got to actually instantiate a list and put it in the variable. That's what we're doing here. We're making two space object lists and assigning them to asteroid list and player list before we do anything else. So then we make an S object, which is just a reusable space object reference. And here's where my cat stomped on my keyboard. Here's where we've created a new object called of type player. So notice how we're using our enum. We got spaceObject.sotype.player is the appropriate way to use this enum in this particular case. And we're passing it into the space object constructor. We know it's a constructor because it's the constructor argument and because we got the word new in front of it. And then we assign what comes out of the constructor to the SObject variable. And then what are we doing? We're initializing the position of this particular space object, the player, to the center of the screen. And then finally, we're adding it to the player list. We do spaceObject.playerList, because that's where the player list is defined, .add, which is a function of the player list, and the argument is this new object we're sticking in this bag. So here's where we actually bag up the player. We create the player and we bag them up right there. Now we've got to do the same thing for the asteroids. We're going to make what looks like 10 asteroids according to this loop. We will create a new space object of type asteroids because that's what we pass in. And then look at this, our initial position of our asteroid in X and Y. We are going to grab a random number and make some random number in there. So we'll set all the asteroids to some random starting position. And notice that we don't just set position X and position Y, we also set velocity X and velocity Y to a random number between -1 and +1. So we're not only giving them a random initial starting location, but also a starting velocity. And then finally, after we've made up and initialized our new asteroid space object, we add it to the asteroid list. So great, we've set ourselves up a player space object and 10 asteroid objects. Unknown content doesn't have anything into it, so wow, look at that. Update has very little. There's actually quite not very much in this update function. But let's look at what we do have. We've got a for each function, and then another for each function, and then E is time in the game, plus equal time in the game. We're obviously incrementing it by the time of the game, by milliseconds. And then base update and we're done. So let's take a closer look at this business of for each. For each is a lot like for, in that it's a keyword in the language that lets you loop through things. And there's no doubt this is a loop. But the for each is specifically designed in this language to be used with container classes like lists. In this particular case, we have a list. It's asteroid list, spaceObject.asteroid list. And what this line says, and it's a little hard to get your head around if you've never seen it before. What this particular line says is we're going to do a loop through all the objects in this asteroid list. And in all the objects in the asteroid list, for each of those, we're going to make a temporary variable called SObject, which is of type spaceObject, and put each individual object in the list at a time into the SObject variable so that we can then use it inside this for each clause. In this case, we're going to use it by calling its update function. So what we're doing is we're going through the list, the asteroid list, and calling update on each individual object in the list. We've got 10 asteroids in the list. We're going to go through this loop 10 times and go through each individual object in the list, and each individual one gets its update function called. Right after that, what do? We've got another for each list here. And it looks just like the one above it. What's going on? Well, what's going on is actually very simple. This first list is about updating the asteroids. The second list is about updating the player list. Now we happen to know that we only made one player, so this loop will only execute one time. Let's look at the draw function. And if you look at the draw function, you realize, boy, this looks just like the update function. We have 2 for each loops, and that's quite true. We have a graphics device clear, and we're clearing the screen to black, not blue, because, you know, it's space, it's asteroid, so it should be black. And then sprite batch begin, and over here at the end, of course, we have sprite batch end. And through this, we've got the asteroids for each list, and then the players for each list. And inside the for each loop, we're doing draw. Up here in update, we did the update function, but here in the draw function, we're calling each individual asteroid's draw function, and then we're calling each individual player's draw function. And that's how it is. If you go back and look, game1.cs really doesn't seem all that complicated. It does some complicated setup in the load content function, but then update and draw are both fairly simple. And if you see, it's because of this really interesting and critical thing that we've done. We've not only put all the various objects of the game into neat lists, but then we've also given them their own functionality to do update and draw. So most of the brains of the game, most of the smarts of having the asteroids go around and having the bullets crash into the asteroids, or having the player crash into the asteroid or whatever, will not go in game1.cs. It'll go in space object. And this is kind of key to the very essence of what object-oriented, not programming, but object-oriented game design is all about. The idea that the world is not actually very complicated, and the programming to make the world is not very complicated. It's about the objects. We build a bunch of objects that individually have smarts, and we put them in lists, and we let them move and draw and interact with each other in such a way that even though the individual objects don't have to be that complicated, and the world doesn't have to be that complicated, the interaction between those objects can be very interesting and complicated and fun. All right, we're done looking at this code, and I hope that you're full of creative energy to do interesting things with it. So I would like to go through some of the possibilities that I think of for what you can do to make this even cooler. Number one, the obvious one, the player needs to explode or die or something when it hits an asteroid. That's a distance check or a collision check. Second, it'd be nice if there were bullets in the game and they were fired from the player. That'd be kind of cool. So make bullets that are fired from the player. You know, you can't blow up the asteroids if you don't shoot the asteroids with something. That would mean making a list of bullets just like we have a list of asteroids and a list of players. We already have the variable, but we don't actually create the list, and we don't make any bullets and don't have any smarts for bullets or graphics for bullets or anything, but I know you can do it. Of course, you know, we may want to make the bullets actually intersect the asteroid and make the asteroid go away. And of course, the classic Asteroids game didn't just make asteroids blow up, it made the asteroids split into smaller, faster asteroids. That's kind of nifty, but I know you can do it. How about making a visible explosion when something dies? A little bit more than we've explored before in this situation. I know that we've put stuff on the screen, but we haven't put something as dynamic and explosive. There are two main really cool ways to make explosions on your 2D video screen. One is the particle system, which we'll get into in this series, but we're not going into right now. The other is a more classic so-called sprite sheet of explosions. In other words, you get several pictures of explosions, and the explosions get bigger and bigger and bigger in successive pictures until they fade away. And often those pictures get put into one big bitmap, and you draw a little bit at a time. That's called a sprite sheet, and more specifically an explosion sprite sheet. And I'll bet if you typed explosion sprite sheet into Google and chose the image option, you would find 1,000 of them. So of course you could add sounds. There's plenty of really distinctive sounds in the old Asteroids game, pew-pews and explosions. But how about a game score that works? Wouldn't it be nice if you actually got scored for how many asteroids you blew up? And how about a high score that works? Now the thing about a high score, of course, is that you have to have a win-loss situation in the game. So you can have a score, like the best score for the game. But then you've got to actually have a variable so that you remember the previous high score, and you can only beat it if you have a score currently better than the score that was last. That's what a high score is. So another thing that you certainly want to do if you're dodging asteroids is dodge asteroids. Use the arrow keys to move your ship around. Now the ship I gave you is not pointed in any particular direction like the original asteroid ship is. And there's lots of possibilities going on there. But you don't have to point the asteroid or the ship in the correct direction. You just have to use the arrow keys. And the last thing would be visibly wrapping the asteroids. Now, I know that according to the code, the asteroids already wrap. But the trick is that they wrap weirdly. They get halfway off the screen and then they blink out of sight and blink on halfway on the other side of the screen. And that's not really how it's supposed to work, and certainly not how it worked in the original Asteroids. The secret is pretty simple. The secret is to redraw the asteroid if it's across an edge. In other words, the simple way is to not only draw an asteroid, but then draw it again to the left and to the right by the width of the screen, and up and down by the distance of the height of the screen. That's, simple, elegant, and maybe a little brute force, but it works. Drawing the asteroid actually 5 times ensures that the asteroid wraps pretty seamlessly. Right, before we go, there's a couple of things in the ideas of how to expand the game that I really feel I need to touch on. They're very important concepts. The first is what you do with that is dead flag. Because if a bullet hits an asteroid, then some piece of code can set the asteroid's is dead value to true. That's the first part of it. That's the easy part of it. Now what? Now how does the asteroid go away and leave the list? Well, I've said before that the asteroid code is probably not a good place to actually make the asteroid remove itself from the list. Let's go back to the code and look. See here in game1.cs, here, after this update function, after the whole update function is done, if I were doing this, I would want to remove the object. I would want to say if s object dot is dead is the same as true. And this is not in the code of the actual asteroid or space object program. It's in the game 1 object, so I think we're safe. So if it's true, then I want to remove it from the list. And the way, and specifically this particular list we would do that is we would type asteroid list dot remove at. And it would take an index. Now, of course, I haven't been dealing with the index of a list yet because, well, we haven't. But there's a particular incantation for how we do that. When we remove things from a list, we have to do so in a kind of a tricky way. Lists are not arrays, even though they masquerade as arrays. And so there are certain weird internal rules. What it boils down to, though, is we can find the items in the list that have the is dead flag set, and we can remove them from the list. But it's important when we're iterating through the list that we iterate backwards just to make sure that we don't disturb the list while we're removing things from it. So if you look at this particular code I wrote, this is in game1.cs's update function. And as you can see, I have a for each for each asteroid, and that's fine. That updates all the things. But now in this update, the asteroid might have found itself dead, might have set the isDead flag to true, in which case what I want to do is remove it, and I'm going to do it this way. I'm not going to use a for each loop, I'm going to use a normal for loop. More specifically, if you look at this for loop, I'm going to count backwards. I'm going to start at spaceObject.asteroidList.count -1, that's however many asteroids are in there. And I'm going to go as long as I is greater than or equal to 0. And each time through the loop I will decrement. I will remove one number from I. Alright, this loop counts backwards. And what I'm going to do here is I'm going to actually take a space object variable called sObject and assign it to each of the asteroids in the bag, one at a time. And I'm going to check if that object's isDead is true, then remove it from the list. So this is pretty much the proper way to use the isDead flag. The isDead flag is a way so that an asteroid can say, oh, looks like I'm dead, I crashed into something, but it's tricky to remove objects from a list. So out here in the Game 1 update is our code that carefully walks through the list backwards to remove dead objects. This is how you remove the objects. And we can do it again for players and bullets and anything else we want to exist for a time in the game. So there's one other thing I want to talk to you about, because how does it become isDead? Well, obviously, if a bullet gets too close to an asteroid, then I guess they both blow up. And that seems reasonable. But what is too close? Well, we've never really discussed that in this series before, but it's actually pretty simple. There are lots of different ways to do collision, and in fact, collision is a deep rabbit hole that we could go down as far as you wanted in video game development. But try to keep it simple. And one of the simplest ways is a simple distance check. So if you look at this code that I added in spaceObject.cs, here in the test in the space object update for as an asteroid, here in the brains of S asteroid, I have a piece of code that goes through each player in the player list. This line goes through each player in the player list for each S-object and player list. So S-object will be a player. We know it because it's coming from the player list. And what we do is we get a vector2 difference between the player's location and my location. That's just a difference. So now difference, like the position of the player and the position of this asteroid, is an XY pair. But specifically, this is the offset. This is how far away in X and how far away in Y the player is from me, the asteroid. And then, of course, I check difference length to get how far away these two things are. And I just check. If it's less than 100, then set it to true. So this code right here is killing asteroids when they get within a circle radius of 100 pixels from the player. Let's give that a try. So we'll run the program and see we've got some asteroids coming closer and closer to the ship. When they get within 100, they should automatically disappear. Oh, there goes one. There goes another. Now you can see other ones that seem to be popping on the screen, but that's actually because of the way we're doing wrapping. So this code seems to work. And this is fundamentally how we're doing collision. We're doing a collision detection by doing a distance radius, and we're doing a collision resolution by going through the list and removing the objects that have their isDead flag set. These are two very important concepts that contribute to this particular assignment. So that's the lesson. Thank you for watching. I'll see you next time.